So what we're going to do now is plot all the G points, and then we're going to compare those graphs. In G, we have the point 0, 3, and that's going to be this point right here, 0, up 3. Then we'll go through 1, 1. That's this same point right there. We're going to go through 2, 4, to the right 2, up 4. We're going to go through 3, 2, to the right 3, up 2. And then we'll go to the right 4 and just stay on the x-axis. Okay. So what happens here when we compare a graph? What we can do is graph the line that goes through 0, 0, 1, 1, 2, 2, negative 1, negative 1. That's the line y equals x. What happens is, if these are indeed going to be inverses of each other, then they should be a perfect reflection across the line y equals x. Because remember what we did back in geometry when we had those points y equals x? We took the point, say, AB, and when we reflected it across the line y equals x, didn't we just switch our a's and our b's? And isn't that really the definition of an inverse, by just flopping those around? Okay, so indeed we can check these, and you'll see that 1, 1 is on both of those, and it's on the line y equals x. And then we have corresponding 0, 2 and 2, 0, 4, 0 and 0, 4. We even have the points here that are 3, 2 and 2, 3. And our last set of points were 4, 2 and 2, 4. You'll see on one side is a blue one, which corresponds to our g of x function. On the other side is a red one, which corresponds to our f of x function. Okay. Now, we won't do that for all of the ones for this second equation. They should all reflect around those, but you'll see we had this point here to the right 5 and down 10, and that is definitely not a reflection across the corresponding line, or what could have been the corresponding line, which was negative 10, positive 10. Those two do not reflect across there. The same thing with this one. We had to the right 10 and up 5, and I probably should change my colors here. The red one, this was the blue one, that was negative 10, 10. That was our g of x function. This was the 10 comma 5 from the f of x function. This one is, this one was 10, 5. This one was the 5, negative 10. 10, 5, and we were over here at 5, 5, which is on the line of reflection. You can see that none of these really line up at all. Okay? The other ones would have. You can see the 0, negative 10, 0, and the 0, negative 10 would have been negative 10, 0, and 0, negative 10. Those would have looked nice and wonderful. But again, all it takes is 1 point for this not to be a function. Okay. So let's take a look at a set of graphs that are given to us, and then we're asked to draw the inverses of those. Okay? Now, one thing we could do is actually draw the line here and do that geometry of redrawing this by doing that reflection. But I think what you probably remember doing is making a set of tables of values, and from those tables of values, switch those around to create our new values. So for example here, you can see that this is at x equals 0, 2. So in our inverse function, when we switch these around, this will be 2, comma 0, that point there. Yeah. There's another point right here that is to the right, or excuse me, to the right 1 and up 3, 1, 3. If we flip that around or take the inverse of that, we'll go to through the point to the right 3 and up 1.
So are we just reflecting that line across the line that we drew, y equals x?
Mm-hmm. And then you'll see that we have this point here. It is the point -1, 1. When we flip that around, we'll have -1, +1. So -1, +1. I'm sorry. Let me make sure I did that right. Yep, -1, +1. So I need to flip those around, and it sure looks like it didn't. This should be a +1 and then a -1. So we'll go to the right 1 and then down 1. And then we have this point that is right here, and not sure exactly where that is. It looks like it's somewhere in between -2 and -1, but it's a line on the line of reflection, so we know that lines, or excuse me, it's a point on the line of reflection. Any point that's on the line of reflection is going to stay on the line of reflection. So it looks like we have enough points here to draw our curve, and our curve is going to look something like the same snake that we had before, but can you see it's changed from a snake to a lazy snake? Mine was a little bit off down here, but yeah, you can see that we started out with this snake, and the inverse is a lazy snake. Yeah. Let's go ahead and check out this parabola over here, and we'll do the same thing. We're going to take some points on our parabola and switch them around. So this point here is 0, 1. That becomes 1, 0. I'll go ahead and plot that as we do it. And the point 1, 2 becomes 2, 1, to the right 2, up 1. And we can go left 1, up 2, which then would be correspond to 2, -1, to the right 2, down 1. And we do have some others up here, but I think we have enough for our parabola that we can plot this guy, and it looks like this. That would be a perfect reflection across the line y equals x. And if you recall from Algebra 2, we even had a test for this. The inverse of a function is always a function if it passes, okay, let me be more specific here. Is the inverse of function always a function? And I'll say only if, since I put that in there, I didn't think my thoughts out well enough, only if the original function only if our original function passes the HLT, not the VLT. The VLT is what we use to check a function. But if I look at the original function, such as this one in red, and I do a horizontal line test, does this guy pass the horizontal line test? Will I ever cross the original function twice with any horizontal lines? So since this passes the horizontal line test, then automatically, without even graphing this, I know that this one will pass the vertical line test. So this one is a function. I don't have to graph it to check it. Okay. Let's take a look at our parabola over here. Does the parabola pass the horizontal line test? No. So, will our inverse be a function? No. Okay. You can see if I wanted to, after I've graphed this, you'll see that this fails the vertical line test, but I don't have to wait and do that. I can strictly look at the original function and know that this is not a function, since the original function does not pass the horizontal line test. Does that make sense?